Here is Unit 6, our first lesson in the unit, which is actually on that sheet. It's actually not in the packet, so this is the handout that you were supposed to take in addition to the packet. And so this unit is about similarity. We're going to talk about what similarity is. So you will be able to describe how similar figures are formed and investigate dilations in the plane and describe a series of similarity transformations that map one figure onto another. All right. The stop and jot is intended for you to do yourself. Make sure that you do have a response written to this question. Which of the following best represents the shape of an iPhone 10 and why? Is it A? Is it B? Is it C? Which one of these most represents that shape? And think about your reasoning as to why. Write that down. That will be checked tomorrow. Dilations vocabulary. And we have been focusing on vocabulary a lot. It's really important, and know that this vocab will end up on a vocab quiz at some point. All right, so describing a dilation requires, so when you describe a dilation, you have to give, right, the center where the dilation is centered and the scale factor. And the scale factor is, if you think about that IXL unit that you did, it's literally what did you multiply X by and Y by in order to shrink or enlarge the figure. Okay, so it is the rate or the value that the figure is increased by or shrunken by. So for example, we can say that if we had the coordinates, 2, 3, and then we are told that we have a scale factor of 3, then we would take 2, or rather 3 times 2, and 3 times the y value, which is 3, and that means that this point would be, right, once it was dilated, would be 6, 9. Okay, so the scale factor is literally the amount that the figure is being either increased or decreased by. All right, here's a diagram example. Here this figure has a center, which is here, the original image or the pre-image, and then the dilated image, which was clearly it was increased, okay, because it's larger than when it started out. All right, coordinate notation. A dilation centered at the origin with scale factor K maps this, just like we did in this example here, okay? Dilations. What is a dilation? So a dilation is a transformation that changes the size of a figure. And a similarity is tied to dilations because when this triangle is dilated, it means that these two figures are similar figures, right? So we talked about congruent figures or congruent triangles specifically. These are not congruent per se, these are similar, okay? And that's because a lot of their properties remain the same, and we'll talk about that. The symbol for similarity is this squiggly line, right? So when you see, like in this example, triangle ABC, and then the squiggly line, that squiggly line means is similar to triangle A prime, B prime, C prime, all right? Two figures are similar if, and only if, one can be mapped to another through a sequence of rigid motions and dilations. For example, in this case, if I translated C along this, right, along this line. I just translated, I moved it a few units so that it got to C prime, and then I dilated it. Eventually, it would end up mapping right over A prime, B prime, C prime. Okay, so that's why they say here through a sequence of rigid motions, meaning more than one. Because if I simply dilated it, doesn't mean that it's going to lay right over that one. I have to translate it, then dilate it. Okay, a scale factor. A scale factor is the ratio of the length of any side of the image to the length of the corresponding side in the pre-image. And I'm going to give you an example with this figure here. So AC is, let's say, 3 units in length, and A prime C prime is 12 units in length. So the ratio is, and we go from the image to the pre-image in order to figure out what the scale factor is, okay? So in order to figure out the scale factor, I take the image, which is the after effect of it being dilated, to the pre-image, which is the before. So 12 to 3, or we could say 4 to 1. Why can I say 4 to 1? Because I can turn this into a ratio, same thing. And then I would get 4, or 4 over 1, okay, which is the same as this. All right. On to the next page. So dilations in the coordinate plane. I actually did this part for us. It says that A prime B prime is the image of AB after a dilation centered at the origin. The scale factor is the ratio of lengths of segments in the image to the corresponding segments in the pre-image, right? And like I said, image to pre-image. Always image to pre-image, not pre-image to image, okay? So the dilated figure is first in the ratio. Use the distance formula to find the scale factor in this example. Be sure to put answers in simplest radical form. Okay, so, excuse me. AB, I went ahead, like I said, and I plugged segment AB and segment A prime B prime into the distance formula, and I ended up getting radical 208 over radical 52. Now, I need for you to make sure that you do the same thing that I did here and understand what you're doing while you're doing it. And then I'm going to actually divide these ratios, or rather divide these two values up. So like I said, I got radical 208 over radical 52. Now, if I simplify these, or I put them in simplest radical form, let's see what they look like. So I'm going to take radical 208, and I'm going to take radical 52, okay? And again, simplifying ratios is super duper important. You got to know how to do that. Find the factors of 208. I always try to find the biggest, the biggest perfect square factor, but you know, in this case, I checked 4 and 4 works. And so radical 4 is a factor of radical 208. And if the factors are radical 4 and radical 52. So I'm going to simplify this. That gives me radical 2, radical 2. These are both prime, so I'm going to circle both. And then radical 52. I know that 52 is divisible into 13. Okay, and then that's going to give me radical 13, which is prime. I'm going to circle it. And radical 4. And again, I'm going to break this down to radical 2. Okay, and so I have, oh no, I should not have circled that radical 4. That was wrong. That was a mistake. Okay, don't circle the radical 4. It's not prime. All right, so I have a pair of radical 2's. Those go outside of the radical sign that I'm about to draw. And then another pair, right? And then I just have radical 13. So this ends up being 4 radical 13, okay? And then again, 52 divided by 4, factors are 4 and 13. I actually should put the 13 here because I'm going to have I'm going to need space. So this is our 13 here. Okie dokie. And then we have 4. And then we have radical 2, radical 2. So we have a pair of 2's that ends up being 2 radical 13. So 4 radical 13 divided by 2 radical 13. Okay, so you do have to simplify in order to get the solution here. These are going to cancel because it's the same value. Radical 13 divided by radical 13 is just the number 1. And 4 divided by 2 is 2. So the answer here is 2, meaning that this is your scale factor. Okay, let's move on to the properties of dilations, but I'm going to make that a part 2 video, so stay tuned.